For this problem, we're being asked to find the length of the diagonal from I to E, so this line right here. Now there is some important other information we're given. We know that the perimeter of the rhombus is 68. Now because it is a rhombus, we know that all four sides of it are equal. So what we can do is take that 68, divide it by 4, and that's going to give us the side distance of all four sides of this rhombus. And 68 divided by 4 is 17. So now we know that all of these distances around the side are 17. And the last bit of information we know is that the line from T to G is 16. So that's this blue line here has a distance of 16. But before I label that, remember that we're dealing with a rhombus here. And there's a special property of the diagonals in a rhombus. In fact, what happens is not only do the two diagonals form a perpendicular lines, meaning that these are going to be forming 90-degree angles, the diagonals also are bisecting each other, meaning that they are cutting each other in half. So if the distance from T to G is 16, we know that because it's a rhombus, that the distance from T to R is 8, and the distance from R to G would also be 8, because that's half of 16. So how are we going to find the length of IE? Well, the trick here is to notice that we've got a right angled triangle. We know one side length is 8, and the hypotenuse length is 17. So to find the length of IR, let's just call it x here, we're going to use the good old Pythagorean theorem. Because we're not looking for the hypotenuse, we are going to be square rooting the hypotenuse squared minus the leg squared. And that's going to get us an answer of 15. So that distance there is 15, call it x. And of course this distance will also be 15. So that means that total distance from I to E is 15 plus 15, or 30. All right, hope that was helpful, and thanks for visiting JD's Preparation.